All right, welcome everyone to the session. This session is deploying Google Kubernetes engine, which will be hosted by Aminu. Introduce yourself.
Good afternoon, everybody. My name is Aminu. I will be your host for this session. Now go on. Can I go?
Welcome everyone to the session. This session is deploying Google Kubernetes engine, which will be hosted by Aminu. Introduce yourself.
Okay, good afternoon, everyone. My name is Aminu. I will be your host. Everybody. My name is Aminu. I'll be your host for this deploying Google Kubernetes engine session under GADS. Now go on. Can I go?
Welcome everyone to the session.
My God, it's sleeping.
This session is deploying Google Kubernetes engine, which will be hosted by Aminu. Introduce yourself.
Okay, good afternoon, everyone. My name is Aminu. I will be your host. My name is Aminu. I'll be your host for this deploying Google Kubernetes engine session under GADS.
Well, Aminu, do you have the live session open on your browser?
Yes, it is.
No, please close it. You only to connect via the Zoom.
All right.
The one on YouTube, please don't connect to it. Close that.
Okay, it's closed.
So. Nadine, are we still live?
Yes, we're live.
Okay,
you can go ahead.
Okay.
Is my screen visible?
Not yet.
Okay, 1 minute. Good afternoon, everyone. So today's lab will be on deploying Google Kubernetes Engine. It's an hour's lab, but we'll try to finish it in far less than that. So I'm about to start lab. I'll open my console in a new tab. Copy my username. Copy my password. So the first task, we are to deploy GKE clusters. Google Kubernetes cluster, Google Kubernetes engine clusters. So I'm still authenticating my login. All right, we are in. So I'll confirm my APIs are all enabled. I'll search for the Google Kubernetes engine. So it's enabled. We can now begin. Going back to the home page. Okay, back to the instructions. In the navigation menu, click Kubernetes engine clusters. Create cluster to begin. All right. Kubernetes engine clusters. Create. Taking note, it says, click the create cluster to begin creating a GKE cluster in the GKE standard cluster option. Select configure in the next screen. So the standard, we configure. And here we are. Change the cluster name to standard cluster 1. Zone to US Central 1A. Leave all the values at their default and click create. So let's change this to standard cluster 1. Our zone is Central 1A, US Central 1A. Leave all the rest as default and create. So it takes a while to provision GKE cluster. You need to wait a few minutes for the cluster deployment to complete. While we are waiting, we could start with got it. Takes a while. Now, while we're waiting for the GK cluster to be provisioned, we might as well have a small review of Kubernetes and Google Kubernetes Engine. Kubernetes, also known as KATES. The 8 stands for the 8 letters in between the K and the S of Kubernetes. Kubernetes is a popular container management and orchestration solution. Kubernetes is an open source platform that helps you orchestrate and manage your container infrastructure on-premise or in the cloud. It automates the deployment, scaling, load balancing, logging, monitoring, and other management features of containerized applications. Deploying Google Kubernetes Engine. Now, Google Kubernetes Engine, GKE, is Google Cloud's managed service offering for Kubernetes. Kubernetes orchestrates containers. Now, GKE maintains Kubernetes. It will help you deploy, manage, and scale Kubernetes environments for your containerized applications on GCP. GKE seamlessly integrates with Google's Cloud Build and Container Registry. This allows you to automate deployment with Cloud Build and using private container images stored in the Container Registry. It also integrates with Google's Cloud IAM, which allows you to control access through the use of accounts and role permissions. Stackdriver is Google Cloud system for monitoring and management for services, containers, applications, and infrastructure. GKE integrates with Stackdriver monitoring to help you understand your application performance. Now, let's go back and see if our cluster has been provisioned. Yep, it is. So our cluster has been provisioned. It has been deployed. Tick, we've gotten our 5 marks. Now click the cluster name, standard cluster 1 to view the cluster details. You can scroll down the page to view more details. Click the storage and node tabs under the cluster name at the top to view more of the cluster details. So cluster 1. Here we have the name of our cluster, the location type, which is zonal. It could also be regional. The control plane zone, which is US Central 1A, which we selected. Default node zones, US Central 1A. Release channel version. Total size of nodes 3. Endpoint automation. Now, what does the instructions say? Click the storage and nodes tab under the cluster name at the top of to view the cluster details, the node and storage. So here you have the nodes. I have 3 nodes assigned. Storage and the logs. Now our next step states modify the GKE clusters. It is easy to modify many of the parameters of existing clusters using either the Google Cloud Console or Cloud Share. In this task, use the Google Cloud Console to modify the size of the GKE clusters. So in the console, we click nodes at the top of the page for standard cluster 1. In the node pool section, click default pool. So nodes, the node pool section, we select the default pool. So here, it was by default, it set 3 nodes. We can resize that to 4 as instructed, I believe. Yes, change the number of nodes from 3 to 4 and click resize. Resize. Now, just like deploy GKE clusters, resizing the number of nodes will also take a couple of time. So maybe we go back to our slides while the number of nodes increases from 3 to 4. So let's get familiar with some of the terms we have used so far and will be using. Most of us here, or all of us, are on the Google Cloud Platform training track. So Associate Cloud Engineering track. So most of us should be familiar with most of these terms, if not all. An image, which I believe so many of us have used in containers, is an application and its dependencies. An application and its dependencies is called an image. Containers is a running instance of an image. These are isolated user spaces for running application code. They are lightweight delivery vehicles for application code. Now, pods. These are the basic units of running containers inside of Kubernetes. A pod provides a way to set environmental variables, mount storage, and feed other information into a container. In Kubernetes, pods are responsible for running your containers. Every pod holds at least one container and controls the execution of that container. When the container exits, the pod dies too. That means the pod is ephemeral. It dies. More on our definition of 10 clusters. Kubernetes lets you deploy your containers on a set of nodes called a cluster. We just did that. We deployed a GKE cluster with 3 nodes, which we increased to 4 nodes. It's a set of master components that controls the system as a whole, and a set of nodes that runs containers. Nodes, which we created 3 by default and increased to 4. These virtual machines that host your containers inside the GKE cluster. In Kubernetes, a node represents a computing instance, while in GCP, nodes are virtual machines running on compute engine. Replica set. This ensures that a set of identically configured pods are running at the desired replica count. If a pod drops off, the replica set brings a new one online as a replacement. Deployment is a higher order abstraction that controls deploying and maintaining a set of pods. Behind the scenes, it uses a replica set to keep the pods running, but it offers sophisticated logic for deploying, updating, and scaling a set of pods within a cluster. Last in the definition, I think, is secrets. These are used to store non-public information such as tokens, certificates, or password. Secrets can be attached to pods at runtime so that sensitive information can be stored securely in a cluster. They are encrypted. Now, let's go back to our GKE cluster and confirm if our nodes have increased from 3 to 4. Yes, it has increased from 3 to 4. Hold on. And we have gotten our point. Now, deploy a sample workload. In this task, using the Google Cloud Console, you will deploy a pod running the Nginx web server as a sample workload. In the Google Cloud Console, on the navigation menu, click Kubernetes Engine Workloads, click Deploy to show the Create a Deployment wizard. So now here, in the Kubernetes Engine, we select Workloads. And we deploy. What are we deploying? We are deploying an Nginx server. Click Continue to accept the default container image, which is Nginx latest, which deploys 3 pods each with a single container running the latest version of Nginx. Click Continue to accept the default container image. Everything as default. Continue with accepted container image. Configuration. Scroll to the bottom of the page and click the deploy button, leaving the configuration details at the default. configuration details, application name Nginx, namespace default, key one is app, and the value is Nginx1. So I would like us to take a look at the YAML configuration file. Of these resources will be displayed. Yes. It might look a bit much, but we'll try and break it down. This is what GKE does for us. It takes care of all this. We just click and select. All right, deploy. This shouldn't take long as deploying a GKE cluster. Scroll to the bottom of the page and click deploy button, leaving the configuration details at default. When the development completes, your screen will refresh to show the details of your new Nginx development. Yes, and it's done. Way faster than deploying our GKE clusters and increasing the number of nodes. Let's check. And we are done. Now on task 4, view details of our workloads in the Google Cloud Console. In this task, you view details of your GKE workloads directly in the Google Cloud Console. In the Google Cloud Console, go to Workloads. In the Google Cloud Console and Kubernetes Engine Workloads page, click Nginx1. You may see 3 pods. 3 out of 3 as the default deployment will start with the 3 pods, but we'll scale back to 1 after a few minutes. You can continue with the lab. Three pods, as said. This displays overview information for the workload, showing details like resource utilization charts, links to log, details of the pods associated with this workload. Scrolling down after the pods, exposing service. So for this exposing service, we are exposing our service to people outside our cluster, but that is outside the scope of this lab. So we check on details. Cluster name, standard cluster 1, as we know. The namespace default, it was created some minutes ago. Labels, all here. The revision history. So this normally works for rolling updates. How many versions we have done, and this is our first version, so it's 1. Events. Wow. And a YAML configuration, we are back to it again. It sure looks like a lot, but we'll try to break it down later ahead. In Google Console, click the details for the Nginx. The details shows more details about the workloads, including the port specification number. We've done that. We've checked the revision history that have been made to this workload, just 1. We've checked the events. And then the YAML tab. This tab configures the complete YAML file that defines this component and full configuration of this sample workload. Still in the Google Cloud Console details tab for the Nginx workload, click the overview tab, scroll down to manage pods section, and click the name of one of the pods to view the details page for that pod. Overview, one of the 3, take the first one. And here are the pod details. Here are the events. We created the Nginx. It was pulled from its image from container registry, successfully pulled image, yes. Started container Nginx, created container Nginx. We have been through the log file already. So now if we were to, it's outside the scope of this course also, this lab, but if we were to run commands on Kubernetes, we would have used the kube control. I call it kubectl, but it's kube control. Now click the YAML tab to view the detailed file for this. The YAML file, I want you to take note of the kind of deployment, kind of workload we're having. It's a pod for the Nginx pod, which we clicked. Now let's go back to the cluster and its overview. And let's check its YAML file. Where do I have access to this? Okay, can't seem to locate its YAML file. We would have shown deployment instead. Now, what are we expected to do? We have to end our labs. Now, before ending our labs, I would like us to scroll to Compute Engine VM instance. Just a small detour. And I want you to take note of the 4 nodes we created. Here it is. The 4 nodes we created in the cluster are Compute Engine virtual machine instances. GKE, what they call, creates, launches Compute Engine virtual machine instances and registers them as nodes. So, what do you know? We are done with the lab. End lab. Submit. Oh, let's keyboard. And we are done. Now, can we go back to our slides? So the last thing I did on the lab, here it is. GKE launches Compute Instance Virtual Machine instances and registers them as nodes. You can manage node settings directly from the Cloud Console, which we will do in the lab ahead. We've already done that. By default, the cluster launches on a single Google Cloud Compute zone with 3 identical nodes, all in one node pool. Number of nodes can be changed during or after creation, which we did. Adding more nodes and deploying multiple replicas of an application will improve an application's availability, but only to a point. What happens when an entire compute engine goes down? You can address this concern by using a GKE regional cluster. So what we did was we used zonal cluster earlier. We created a GKE in US Central 1A zone. Regional clusters have a single API endpoint for the cluster. However, its control planes and nodes are spread across multiple compute engine zones within a region. Regional clusters ensures that the availability of the application is maintained across multiple zones in a single region. Kubernetes object management. Now for our YAML file we saw. I'll try my best to break down. I won't call it the most important, the most visible aspect. Kubernetes object management. These are entities that are used to replace the state of the cluster. Objects are defined in the YAML file. Now, the API version 1 here, it's the kind of Kubernetes API you are using to create the object. For the kind deployment, we showed a deployment earlier and pod. So there are different kinds. There are cron jobs, it goes on. Metadata, data that helps you uniquely identify the object, including a name string, UID, and label. The state, what state you desire for the object. That's okay. So GKE Autopilot, it's another offering from Google Cloud. It's a revolution in managed Kubernetes. GKE Autopilot is a revolutionary mode of operations for managed Kubernetes that lets you focus on your software while GKE Autopilot manages the infrastructure. So how do I put this? Kubernetes orchestrates containers and makes it easy for you. GKE makes managing Kubernetes easier, while GKE Autopilot makes GKE even easier. That's like 3 loops. GKE Autopilot makes GKE easier, while GKE makes Kubernetes easier. So you can have a look at this. Check it up. It was a new offering from Google Cloud. It came out early this year, I think. That will be all for my presentation. I hope we have demystified Google Kubernetes engine together. Now, I think there should be space for questions.
All right, thank you, Aminu, for that presentation. Apologies for the technical issues in the beginning.
No problem.
All right, so are there any questions, Say or George? Are there any questions you have?
None. None from my end.
Okay, a learner is asking if the slides will be available. So, Amina, will you be able to share your slides?
Yes, it
So
will
we
be
can share
available.
this.
I think
All right,
George will make sure it's shared.
Okay. So thank you very much. We'll make sure the slides are shared with everyone. So just be on the lookout for that on the community platform. So I think that's all for today. Has any one got any more comments? George, do you have something to add?
I think Aminu covered all the basics in terms of deployment, and of course, like every tool on every cloud provider, you decide which is best for the kind of work you're trying to do. So where you're trying to deploy quickly, in terms of maybe testing or production deployments, or you don't have the technical know how to manage certain aspects of your project, then GKE is a good tool to use. They take care of the management of a lot of it security wise, and of course, like Aminu said, autopilot takes care of a lot, and it's a bit cheaper than the regular standard mode of deployment for GKE clusters. Nadine.
Okay, thanks a lot for that, George. If learners are still on YouTube, if you have any questions, please drop your questions in the chat so we can address them. We have about 10 minutes remaining. Okay, so it seems as though we don't have questions coming through, but we will share the slides. The recording will be available. You can reach out on the community platform, and I will also share some credits so you can do extra labs if you're interested in practicing more quick labs. Okay, so there is a question that came through. What are the basics of GKE? Aminu, do you want to take that question?
What are the basics?
Yes. It's a very general question, I think.
Funny enough, I don't get it. The basics, how? Foundations?
In terms of, is the person, maybe let the person make it a bit more, is it specific? Is it in terms of operations or in terms of the basic building blocks of GKE? Which is it?
Yeah, I think that question needs a little bit of elaboration, but the person is asking, what is the work of GKE in machine learning using GCP? So do you know anything about how GKE can be used in machine learning?
How many are you taking that?
I'm not, because nothing comes to mind.
Okay. Well, let me take that. In terms of machine learning basically is you're looking for a machine that can handle your workload and do the stuff you want it to do. You're trying to do something with your data. So GKE comes into mind in terms of the available machines, because when deploying, the mode in which Aminu deployed, which is the standard mode, there you can decide the type of machines you want to deploy to your pools, cluster pools or node pools, unlike autopilot. So someone trying to do machine learning on GKE would use the standard mode of deployment and not the
Okay, thank you very much, George. Someone asked, how do we get access to credits? So all the labs you do on Plural sites are free. But if you want additional labs to do, I will share some codes that will give you access to credits. So after these sessions, after today, I'm going to drop some codes that you can use on Quick Labs. Okay, so there's another question. What is the value proposition of the GKE pilot? So, Aminu,
The
you
value
want to take that?
it's way cheaper than GKE, if that's what you're asking about.
Yeah.
For the exacts, I don't know. Okay, George is back.
If I may add on to that, in terms of cheapness, that's 1, 2. In terms of implementation of best practices, Google does that for you. Okay, unlike the standard edition mode deployment method where you need to take care of that yourself. Autopilot actually makes sure your deployment is efficient in terms of cost, in terms of availability, in terms of scaling. You don't need to set up scaling configuration. It does that for you, It just takes care of a lot of stuff. The only limitation currently for that type of deployment method is the fact that certain deployments for now are restricted. It's not in full. It hasn't entered GA, general availability. I think it's still in beta or thereabouts. So for now, some workloads can't be deployed there. But in terms of advantages, those are the advantages that you get when you use that mode of deployment.
Okay, so maybe you can take the next question as well, George. Why would you choose GKE over App Engine?
Well, like I said, App Engine usually is if you want fine-grained control in terms of configurations, you want to really get into your machine and do some stuff. You're doing more of testing. You wouldn't want to be testing stuff on GKE, which of course would be more expensive. Oh, sorry, App Engine. My mistake. I thought it was Compute Engine. So App Engine, App Engine has limits in terms of you have 2 modes. Then one mode you can use containers. The other mode you can use containers, but it is not as flexible in terms of configuration when compared to GKE. So that's a major disadvantage of that other one. And of course, App Engine is better suited for bit smaller deployments when compared to GKE. GKE, you're talking of clusters of machines a lot. So if you're trying to do that, then the best deployment tool will be GKE and not App Engine. Nadine?
Okay, thank you very much, George, for that. I think we're going to end the session now. So thank you, everybody, for attending. Thank you for your questions. You're welcome to ask more questions on the community platform. We're also going to be having 2 other sessions, one for Android and one for mobile web specialists, and you're welcome to join. So have a good afternoon. Thanks, Aminu. Thanks, George.
Bye-bye, everyone. Have a nice day.
Hi, Nadine. Can you hear me?
Hi, everybody. Welcome. We're live.
Hi, Nadine. Can you get me?
Hi, Tims.
Yeah. So we're going to have Sibosis will take us through the connecting to the internet. So it seems we have some technicality connecting to Charles. So we'll have Sibosis will take us through. In case of anything, then I'll jump in.
Okay. Thanks, Tim. Welcome, Sibusiso, to the session. Sibusiso, would you like to introduce yourself?
Can speak.
Yeah, Sibosis, I think we can get you. Even though we can't get to see the microphone on Zoom, so you can just introduce yourself.
I did not hear. Morning, guys.
Good morning, Sibusiso. Welcome.
Morning, Nadine. Morning, teams. I missed everything. Yeah.
Okay, would you like to introduce yourself, Sibusiso?
Oh, I'm Sibusiso Kumalo. I'm a freelance software developer down in South Africa.
All right.
That's
Thank you. Welcome. Welcome. Tims, would you like to introduce yourself?
Yeah, sure. Thanks so much, Nadine. So apologies for the inconvenience, but as the Android team, we are always one plan. So we are going to have Sibusiso take us through. So my name is Tim Owen, part of the technical and the program assistant for the Android track at GADS 21. Back to you, Nadine.
Thank you. Welcome, Tims. Sibusiso, I'll hand over to you. You can start sharing your screen.
Sibusiso, you're muted. You're muted. Hi, Chief. You're muted. Can get you.
You can hear me now, man?
Yeah, we can hear you now.
Yeah. Okay. So we're already live.
Yeah. We are live. In fact, we are late. Yeah. You can just click off direction.
Sorry, guys. Today we're going to be doing it's basically permissions. Since Android changed its rules that you need the user's permission in order for you to access the internet. So we're going to be doing a small project on internet connection. I'm going to share my screen now. It's a small app that which is very basic. What I'll do is that I'll give a link to the tutorial where you can actually follow along because you start the project from scratch. What I will highlight to you now is that, let me share this. Can everybody see my screen?
Yes, we can see it.
Yeah, okay. What I want to highlight to everybody is that, so basically, this project is just a small, sorry guys, just a small little project. What it does is that it actually uses the REST API. I'm sure most of you, if you're not aware, most of the information that we get from the internet at the moment, we get it from the REST API, which is just a server which uses the HTTP protocols, which is get, post, update, and I forgot the last one. But what Android does is that we use a library from, or this project uses a library from Retrofit, which makes it easy for you to do those requests. The library, the server that we are hitting here is from, it's from Stack Overflow, where we get all the questions that people post from their Android questions whenever they have a problem. So basically, this project is broken down, or let me say, it is, sorry guys, it is broken down into 4 what you call packages, just to make it the project modular. When you use Retrofit, just hold on guys. Sorry, Tins. When you use Retrofit, there are a few things that you need to implement when you use Retrofit. Basically, you need to do base URI, which you put into your REST client. So all this is basically an object class, which is the REST client, which defines the base URL, which defines the member for the Retrofit, which is given to which is initially set to now. Now, what I do is that I create a variable, which is a client, which is also a Retrofit, but we use the Retrofit builder class to do the request of how to build the Retrofit object. And then another class that or another library that we get is the JSON converter factory, which we use to ask Retrofit to convert its request so that it's easy for us to manipulate it into our project. From there, you basically make a model, which is like, how you base your model is basically you look at what the server serves you at your JSON file, which will be, I'm sure, just hold on guys, sorry about that. It's a JSON file. So if you go to it, I'm basically getting the title and the link from the JSON file. I just wanted to show you the JSON file.
Sibu,
yes.
I'm so sorry to stop you. It seems we're not live, actually.
What?
Oh, I'm really sorry. Wow. Okay.
No, I think that's
wait.
I can put everything where I need it to be.
Okay.
Because of that link.
Okay. Okay. Cliff will join and then he'll take us live.
Let me just go to my settings and increase the volume of my mic, right? Is it better now?
Yes, we can hear you.
You can hear me better now?
Yes.
Okay.
Yes.
Okay. Then you'll tell me when we are live, then I'll be able to share my screen.